Great. All right. Lesson 4.1. Right triangle trigonometry. Which, if we happen to be lucky, will be reviewed from geometry, but it certainly may not be. We're gonna do it like you've never heard of it before in your life. Okay. Trigonometry is built around right triangles. Hence the name, right triangle trigonometry. There are 3 primary trig functions. They're also called trig ratios. 3 primary trig ratios. Functions. While we're learning right triangle trigonometry, we'll think of them more as as ratios, and then we go to graph them, then we'll graph the functions. Okay. When we represent an angle in trigonometry and in geometry as well, we use a Greek letter. This letter is the Greek letter theta. And it means angle. Okay. That looks like a mess. There we go. Add something for some clarity. Okay. Now, when I am looking at this angle, there are 3 different sides. One of them we know the name for. Which one? Hypotenuse. The hypotenuse. Hypotenuse has got a name that we've known for a long time. Which one is the hypotenuse? Yeah, the one across from the 90-degree angle, the longest one, right? It's always, and this is important because this one and this one, both, as far as English are concerned, have the name of one of them, but the hypotenuse is always the hypotenuse. So it is not the adjacent. Adjacent makes sense. What does the word adjacent mean? Next to. So that makes sense. So easy peasy. Then the one opposite the angle, it's called the opposite. Whoa. Nothing too earth-shattering so far, right? No big deal. There are 3 ratios that we can write with these. The first ratio is called sine. Which is spelled S-I-N-E. We abbreviate it with S-I-N. So the sine of theta. We say this, the sine of theta. Kind of like the log of x, right?
Could you say the sine of the angle and the...
Yes, yes. Sine of theta. And that equals the opposite over the hypotenuse. This makes sense so far. Easy peasy. You're like, this is review. You were right. That's totally fine.
The one that my dad was super excited for me to learn. Like,
nice.
learn what a SOHCAHTOA was.
Yes, we're actually going to do that in a minute. Because I also use that acronym. Cosine is the next one. And we abbreviate it cos. cos. So we'd say that's the cosine of theta. And that is the adjacent over the hypotenuse. And the last one, the last trig ratio is tangent, which is different, and it's the same word, but it's not tangent to a circle, like a line that just barely kisses a thing, right? This is same word, different meaning, right? Happens in language sometimes, and we abbreviate it as tan theta, and it is the opposite over the adjacent. And as Alexa alluded to, there's a way to remember it. You can remember it like this. SOHCAHTOA, which kind of sounds like an Indian word. It's not, but you know, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Easy peasy so far? No big dealio?
Yeah.
No problem.
Trying to figure out writing down some of my brain remembering.
SOHCAHTOA.
I write it like this. Or like little waterfalls.
Okay. Now, this is actually, we'll talk about this topic a lot in the next chapter, not the next lesson, but the next chapter, but you're going to learn your first three identities, actually. Well, these are identities as well, but there are three more that are directly related to these. These are the three reciprocal trig ratios. And we talk about them at this part, even though we talk about identities and stuff mostly in the next chapter, we talk about these because they have special names too. And the way I think it's easiest to remember which one is which is S to C and C to S. I'll show you what I mean here. You may want to put that with this, possibly. It goes with this. Okay? So, cosecant which is also another word. Secant is another word that we see in geometry, but we're not talking about the same, we're not talking about secant line, right? Same word, different meaning. Is abbreviated CSC of theta, and it equals 1 over the sine of theta, which would mean that it would equal the hypotenuse over the opposite. Let's see. S to C. We got our first S to C. Sine goes with cosecant, right? And then the next one is secant. And we abbreviate it SEC of theta. And it is 1 over cosine, which would mean that it would be opposite over adjacent. Easy money? Oh, sorry, I wrote that wrong. Hypotenuse over adjacent.
Okay. It's like, I think that
Wait a minute, that can't be right. You are correct, that isn't right. Hypotenuse over adjacent, which would be 1 over cosine, reciprocal of cosine. So S to C, sine Sine and cosine are reciprocals, and C to S. Cosine and secant are reciprocals. S to C, C to S. And then tangent's reciprocal is easy to remember because it's just cotangent. Cotangent. And we abbreviate it COT, cot. And it is 1 over tangent, which means that it is adjacent over opposite. Makes sense? Easy peasy lemon squeezy?
S to C, C to S.
It's just a way to remember. Let's do an example. We're going to do guided practice 1A on page 221. Which has a triangle that looks more or less like this. And it has the theta drawn right there. And it has 5, 12, 13. And we are asked in the problem to find the exact values of the 6 trigonometric functions of theta. So the sine of theta in this instance would be what?
1 second. So which one do you want for sine?
Sine.
It's going to be 5 over 13.
Yeah, so the opposite of the hypotenuse would be 5 over 13. Cosine would be what?
12 over 13?
Yes, you're right. I just wanted Garrett to be able to get caught up writing so that he's not just copying and can know what. That way he gets instruction out of it as well. Sounds good. This isn't a dictation class. So Garrett, what would cosine be?
It would be 12 over 13.
Yeah, that's right. Great. So then, everybody, what would tangent of theta be?
5 over 12.
5 over 12. And then cosecant would be 13/5. Which you could write as a mixed number, or you could just write it as an improper. That would probably make the most sense. Generally, at this point in math, I always write answers as improper fractions until it makes sense to do otherwise. 12ths, and the cotangent would be 12/5.
I wrote them forward. That's the answer?
That's the answer, all of that. All right, do 1B, ready, go, and then we'll compare notes. Because it kind of changes things up a little. All right, did y'all get the same things? If not, let's figure out why not.
No, I got that one wrong.
I need my okay, so
Okay, so we got some erasings and marks. So let's talk through where we were and where we need to go now. So which one is opposite to this theta?
20.
hold on.
I mean, not 20, 21.
21,
Oh, yeah.
right? So this is opposite of this angle. Which one is adjacent to this angle?
20.
20.
Oh.
And which one's the hypotenuse?
29.
29.
I had all that, but I was trying my best to remember the acronyms without actually looking at the notes.
Ah, well that's good. That's good practice. That's probably smart, actually.
I was trying to make up acronyms for the reciprocals.
Ah, S to C, C to S. Do these and then.
Yeah, and you can show them. Okay.
Does that make sense?
Yeah.
Yep. So really, the only ones you have to hardcore memorize are these, and then memorize C to S, S to C, and then cotangent, and because then you just flip stuff over.
Okay, that makes that so much
Good.
easier than having to remember what
Yeah.
stupid
I like tricks to where things are easier. That is nice. That makes our life easy. That life's good.
The longest one.
So always the one, and it's always the one that is opposite the 90-degree angle. Always.
Okay.
Both of those things are true. Yes. All right. Let's do another thing. Let's do guided practice 2 on the same page, and play with some square roots because we're going to play with those a lot with trigonometry. Y'all are, I think, already half decent at doing this, and you're going to get even better at it.
Where's GP2?
At the very bottom of the page. Okay, so GP2, if the tangent of theta equals 1/2, find the exact values of the remaining 5 trig functions. That certainly does not look like half. What is that? How is it not? Maybe it is. I don't know. Doesn't matter. Irrelevant.
How do you do this?
Yeah. How on earth, right?
Pythagorean theorem.
True enough. So we pick one of these angles as a theta. Who the heck cares? It could be this one. It could be this one. But the way I drew it, this is opposite and this is adjacent, but you know, whatever. So I'm going to make this one be my theta. Opposite over adjacent. And then yes, we'll use the Pythagorean theorem.
Plus 2 squared, so that gives you 5, and then square root of 5 is square root of 5.
And that's true. So 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. C equals the plus or minus, technically, right? Square root of 5, don't want to forget that, but we're talking about distance. So, yeah?
Only b plus, really.
Yes, exactly. If it was talking about displacement, it could be negative, but we are not. We're talking about distance. So we throw out the negative one by taking the absolute value. Great. Now, let's write the trig functions. So the sine of theta would be what?
2 over the square root of 5.
Sine, not cosine. Opposite of theta is 1. Opposite over adjacent. That's all right. It's good. So 1 over the square root of 5. Problem, red flag, alarm bells. What's the problem? We can't leave that. It's ugly. We don't like it. What's wrong with it? What do we need to do to fix it?
Square the whole thing?
That's a good thought, but no, that would give us tangent squared, and we're not ready to deal, or excuse me, sine squared, and we're not ready to deal with that. How about we do these? You will almost certainly get, we're going to do this so much that you're going to get to where you can do this without writing this intermediate step, almost certainly. But how about we do that? So it equals the square root of 5 over 5. And then the cosine of theta would be what? Ka.
Is that the 2 of the...
It would be 2 over the square root of 5, which we got a problem. I'll go ahead and write out the steps. Eventually, I'm going to stop. So 2 times the square root of 5 over 5. And the tangent we already know, so skip it and come back. Cosecant would be what?
5, the square root of 5 over 1.
Yes, which would just be the square root of 5, right? And then secant would be what?
The square root of 5 over the square root of, or 2 times the square root of 5.
Square root of 5.
You flip it all the way. Yeah, you were getting there. You knew what to do. You're just coming out whopper jawed. At least that's what it sounded like. Wait. Did you say wait?
I did say wait.
I'm waiting. Waiting.
Square root of 5 over 2?
Yeah, because it's secant is just cosine flipped over, yeah?
Oh, yeah.
Right?
I was flipping the wrong one.
Gotcha. And cotangent would be what?
Be 5 over 2 times the square root of 5.
It's tangent flipped over.
2 over 1.
Tangent flipped over would be 2.
Hello.
What's up, buddy?
Oh, that's scary. It's not scary.
It's not scary. It's easy
Walking into the middle
money.
looks scary. I know it's not scary. Walking into the middle of it looks scary. Test corrections.
It's actually pretty easy.
Test corrections are my picture.
Okay.
Because I couldn't figure out how to use the regression thing.
Didn't we figure it out the other day?
Yeah, I have this, but I don't know what to do.
Oh.
It's like, I guess I got it wrong because it's not supposed to be bigger. It's supposed to be smaller.
Okay. That's all right. Yay. Okay. Here we go. Keep going.
I don't like this at all.
You got it, Eric?
You don't like this? This is like the easiest thing we've done all year.
My brain doesn't want to remember that stuff.
You only have to remember 3 things, 3 ratios. SOHCAHTOA, that's the only thing right now, that's literally the only thing. That and S to C, C to S are the only things that you got to remember. SOHCAHTOA, and then C to S, S to C. If you remember those, you got everything else. Because it all just kind of like unfolds from there. Now there's the next thing I'm about to show you. You are going to have to remember something, but if you can count to 4, you can memorize this one.
1, 2, 3.
So we're gonna like this one. Because there are 2 special right triangles. And then we're gonna also sneak in something from the next lesson because 0 and 1. Special right triangles. Okay. The first special right triangle, we're actually going to write it second in the table, but the first one is the kind of triangle that this thing is. What kind of triangle is that?
45, 45.
That's true. That's not what I'm asking for yet, but yes. What?
A right triangle.
It is a right. That's true.
Isosceles.
It's isosceles, yeah? Okay. And an isosceles triangle has two 45-degree angles and a 90-degree angle. So therefore, this is a 45, 45, 90 triangle. It is very, very important, by the way, that you write your degree measures with the degree symbol, because in the next lesson, we're going to learn the other, more superior unit for angle measurements, radians. And radians has nothing there. So if you just write 45, then you're saying 45 radians, which would be like going around a circle a whole bunch of times, and we don't want that yet. So make sure you put your degree symbol. Okay, so let's talk about the ratios on a 45, 45, 90 triangle. So if we say that this is side length 1, what else do we know about this triangle?
You know that the bottom's the same.
This one's also 1. And by the Pythagorean theorem, 1 squared plus 1 squared equals c squared. C equals the square root of 2. Square root of 2. So, the ratios for a 45, 45, 90 triangle are this. Sine, I promise I'm going to show you a way to memorize these like super easy. This, by the way, this right here is the part where you will have a no calculator portion. So these are the ones that you got to memorize without a calculator.
Memorize.
Yes. So the sine of theta, either theta, right? So sine of 45 in this case, yes,
Oh, yeah.
is 1 over the square root of 2, which after it's rationalized would be the square root of 2 over 2.
And this is what?
The sine of 45. So katoa. Open your book to page whatever it is on the beginning, and that'll maybe kind of be able to jog you enough that you can follow along well enough to go back and watch the first part of the video and stay as caught up as you possibly can. Okay. The cosine of 45 degrees would also be 1 over the square root of 2, right? Which when we rationalize it, it would rationalize into the square root of 2 over 2. The tangent would be 1 over 1, which is 1. Now remember, the reciprocal ones are like uber easy, right? We just flip these over, so we don't have to put we won't make a, well, we may make a table of it, but you don't really have to memorize it because you just have to memorize the base ones and then flip the other over, yeah? So it's 1, and then the cosecant will be this flipped over, so just square root of 2, right? 1 over square root of 2 flipped over would be square root of 2. What? It is a 1, because tangent is opposite over adjacent, so 1 over 1 is 1.
What's that thing?
Cosecant,
What?
CSC, which is 1 over sine. Secant,
How do you word it all again? Sec.
SEC, would also be the square root of 2, right? And the cotangent of 1 over 1 is 1 over 1. Or cotangent. 1 over 1 flipped over is still 1 over 1 is what I'm trying to say. So the cotangent is also 1. Easy money so far? This is just going to be something that you're going to memorize. And I, again, promise, I'm going to give you a nice, easy way to memorize it. And all you have to remember is how to count to 4. Okay. The next special right triangle is this one. And I'm going to kind of build this one a little bit at a time and explain what's happening and why it's special and all the things. Oof. So the first triangle I'm going to draw here is not a 90-degree triangle. And I'll explain why in a second. I'll draw a bigger one that's the actual special right triangle in a second. What kind of triangle did I draw?
Equilateral.
I drew an equilateral triangle. What do we know about equilateral triangles? All sides are the same and all angles are 60 degrees. So if I wanted to turn an equilateral triangle into a right triangle, what's an easy way to do that?
Take something and put it.
Just chop it in half.
Oh, yeah.
Right? So we can take this guy. These guys are all 60, right? And this guy. And we can chop him in half with the great scissors of destiny and turn him into a 30, 60, 90 triangle. Which looks more or less like that. I don't care at the moment about making it perfect. So this angle would be 60 degrees, right? Because we chopped it out of there, which would make this one 30 degrees. And that's the 90, of course, right? So this is our second special right triangle, a 30, 60, 90 triangle. So we need some numbers to make some as nice a ratios that we can do, and the most reduced ratio. So the easiest way to do this, so we don't want something smaller than 1, is to make our equilateral triangle have sides of 2. If we make our equilateral have sides of 2, then this one has a side of 2. And this one is 1 because it's the chopped in half one, right? This one we need the Pythagorean theorem for, right? So we've got 2 squared equals 1 squared plus b squared, right? So 4 minus 1 is 3. And so we've got b equals the square root of 3. So this side is the square root of 3. And that's the most reduced ratio we can get for that guy.
What are the rules? That's my brain I like to brain. Okay.
I think it takes you a long time to write down, and so sometimes you're like not being able to listen and write down. So I say things and then you are like, wait, what happened? I think that's kind of what happens sometimes. Is that what happened? I did the Pythagorean theorem messily in the middle to get this. This is the hypotenuse.
Why did you, where did you plug in the variable? It wasn't in C, it was at B. Why?
Because the hypotenuse is C.
Specific letters?
Hypotenuse is C, always C. Hypotenuse is always the one that's by itself, and it's the one that always matters. This has always been true. A squared plus b squared equals c squared. So it matters which one's C, right? Because so the hypotenuse is always C. It's always the one by itself. Okay. So the sine of 30 degrees would be the opposite over the hypotenuse, so 1/2. The cosine of 30 degrees is adjacent over hypotenuse, so square root of 3 over 2. And the tangent of 30 degrees, that 3 had a weird vacation, would be 1 over the square root of 3, which rationalizes to the square root of 3 over 3, right? And then the reciprocal ones, just flip these over. So the cosecant of 30 degrees is 2. And the secant is going to flip over square root of 3 over 2. So it's got to rationalize into 2 times the square root of 3 over 3. And if I need to, let me walk that one out over here just in the margin just to, so it'd be 2 over the square root of 3, and then we got to rationalize it, right? So times the square root of 3 over the square root of 3, which gives us that, right? And then the tangent, same idea, we got to rationalize the thing. No, the cotangent, thank you. Thank you and me. Okay, cotangent of 30 degrees would be 3 times the square root of 3 over 3, which reduces even further to the square root of 3. Okay, sine now, excuse me, the cosine, yeah, no, what am I saying? Sine of 60 degrees would be from this one. So the opposite over the hypotenuse, so square root of 3 over 2. You notice it kind of flips with these, right?
Did you already write all of these in 90?
No, we'll put that in the chart. Because we don't really talk about that until the next lesson, but we're going to add it to the chart because 0 and 4. Cosine of 60 degrees would be the adjacent over the hypotenuse, so 1/2. And
You know where they come from because why?
you know where what comes from. What you mean?
Which side?
Because of where they are in the on this triangle. So this is opposite this one, this is adjacent this one, and this is the hypotenuse. But the 30, this is opposite, and this is adjacent, and this is hypotenuse.
And you know which ones to use
Because I wrote it right there.
Oh yes.
The sine of 30.
You know to use the adjacent one or the opposite one.
Because of SOHCAHTOA, which was the part because that's how they're defined. It's because they're defined. Sine is opposite over hypotenuse. Yeah. Okay. Tangent of 60 is square root of 3 over 1, which is fine. And then the cosecant of 60 would be these one flipped over. So 2 times the square root of 3 over 3. Secant of 60. My hand doesn't like to write at this angle. It's fine. Would be cosine flipped over, which would be 2. And the cotangent of 60 would be tangent flipped over, which would be 1 over the square root of 3, which would be the square root of, that's the one, square root of 3 over 3. Now, that's all great and all true. That looks like a terror to memorize. I'm going to show you an easy way to memorize it. Because, I don't know whether you were here when I said this or not, but this, what's on the whiteboard right now primarily, is going to be in a no calculator portion of the test. You must memorize these. Okay, so let me show you a nice way to memorize it. By the way, on the test, on the no calculator portion, what I would do is the very first thing when you open the test is write down SOHCAHTOA and this table that I'm showing you. Just jot those down at the front. Because if not, when you get to the problem, it's going to ooze out your ears and you're going to forget even though you knew it 2 seconds ago. So, there it is. Okay, so here's the table. And here's a great way to memorize it.
This is all going to be a long table.
Kind of. This is really the only one you have to memorize. We'll go ahead and, for the sake of notes, put the reciprocal table underneath it as well. But you don't really have to memorize the reciprocal one. You just have to remember the reciprocal are these ones flipped over, right? So, here we go. Are you ready?
No. 1 second.
Okay.
No, I'm ready.
I said all you have to remember how to do is what?
Count to 4.
Count to 4. Sign of 0. Now, we'll explain the 0 and the 90 in the next lesson, kind of where they come from and how it works, because it's easier to explain with unit circle. So just trust me that these are the things, and then in the next one you'll see why. 0. 1/2 square root of 2 over 2. Square root of 3 over 2. And this one, so it's 1, but if it helps you, because 1, 2, 3, 4, then you can remember it as the square root of 4 over 2, which of course is 1. And then cosine does the same thing but backwards. Three over 2, square root of 2 over 2, 1/2, and 0. And if you prefer, you can even put 0 over 2 if you feel like that helps you memorize it. You don't have to, but you can. Whatever makes it easier for you to memorize. And then tangent, this part, so this part you need to memorize. Tangent you don't actually have to memorize, because tangent is, I'm going to give you this, this is a freebie. Can't remember if this book gives this now or not. This book does not. Oh, just kidding, it does. I'm going to teach you your actual first identity after reciprocal ones. So here's your first other identity. Tangent equals sine over cosine. Which means that by extension, the cotangent equals cosine over sine. If you wanted to go nuts, you could say that tangent equals the secant over the cosecant, and cotangent equals the secant. I think I said that backwards, but you follow what I'm saying, right? So this is 0 over 1, which is what?
0.
0.
Right.
That's okay. And this is 1/2 over the square root of 3 over 2, which would be 1/2 times 2 over the square root of 3, which would be 1 over the square root of 3, which rationalizes to what?
Square root of 3 over 3.
Yeah, 1 over the square root of 3 rationalizes to the square root of 3 over 3. This one's square root of 2 over 2 over the square root of 2 over 2.
1.
So it's 1. Yeah. This one, same idea. Square root of 3 over 2 over 1/2. So that'd be times 2 over 1.
So you all
Square
those
root of 3.
numbers coming from things above it in the chart.
Yep. And then this would be 1 over 0, which is what? Nope, that's not true. Stop, go back, think about it.
0. 1 over 0.
Punch it on the calculator. It'll refresh your memory. Push 1 divide. Yeah, undefined. Which is going to tell you later when we graph these suckers, there's an asymptote there.
Oh, fun.
That's fine.
So fun. Okay, how we doing? Pretty good?
So how do we count to 4 in this speed?
0, 1, 2, 3, 4.
I
4, 3, 2, 1, 0. And then these you just get from this fact.
and
Garrett, mira. Don't like freak yourself out. You got to memorize this. You can memorize that. That's easy. Yeah. Tangent, cosine, or cosine. And then 0 divided by 1 is 0. This divided by this is this. This divided by this is this. This divided by this is this. Etc.
just, if I count to 4, 0, 1, 2, 3, 4, the first two are not square root, and I probably will forget that.
Well, you need to work on it. Flashcards today. Try the flashcards. Have you ever tried them? You should try them. Try them sooner rather than later. See if it helps. Takes a few seconds to make, possibly lots of benefits for later.
And also, it is technically square root of 1 and square root of 0. They just equal themselves. So.
What?
You can technically write it as square root of 0 over 2 and then square root of 1 over 2, like square root of 0 is 0 and square root of 1 is 1.
That's true. That's true. That is, and that may help. That's true. Yeah, it could be all this. You could put square roots on the top, and then you just need to be like, oh, square root of 1 is 1, and then yeah. And same for this one. Like square root of 4 is 2, so it's 2 over 2 is 1, right? Yeah. Yeah. Same idea. Okay. How we doing? We need to do an example of this, or so. That's funny. They give you special right triangles, and then they don't give any examples over it. That's kind of funny.
Does anyone know what number example this is? We're not sure yet. Try to find one.
Well, I may have to make one up or look at the homework set to find an exact answer one.
I've done 1, 2.
That's funny. They don't even have it in the homework.
Yeah.
Oh, they just have really, really simple ones.
And then we've done.
So let's make up a harder one. So this I'm going to do 2 of these, just kind of quickly-ish. I will note, if you look at, because doing problems like example 3 and example 4, well, example 4, I need to show you something else, but example 3, they're easy. You shove it in the calculator. Like that one where it would be the cosine, because it's adjacent and hypotenuse. So the cosine of 42 equals x over 18. So 18 times the cosine of 42. We probably will get time to do it, but just in case we don't, like it's excessive, like you just, now the one thing you do want to make sure on your calculator that this is going to be something you're going to want to be making sure of as we go, because like I say in the next unit, we're going to learn, next lesson, we're going to learn a new measurement. Your calculator, if you're doing something in degrees, has to be in degree mode. So make sure you know how to switch between degree mode and radians mode, because if you're in the wrong mode, you'll get the wrong answer. Because the sine of 2 degrees is very different than the sine of 2 radians. Okay.
I have a degree, or I have a theta button.
Great. It's not going to be there. It's going to be, it's right there. You want that says rad to say deg. And it's going to be in mode right there. Yep, that's right. Okay. And then you go, okay, so that's exactly right. Okay, I wanted to make sure I was right before I show you. It's easy peasy. Yeah. You just hit mode, and then you go down and say, I don't want radians, I want degrees. And then enter to save it. And now it says deg. And then when we get to the next lesson and you're supposed to be in radians, make sure it switches to radians. And switch it back and forth and all the things. Okay, so I'm going to make up a problem or two real quick. Here we go. So example something. Sure, why not? I mean, but it doesn't match example 4 in the book. But that's fine. Great, here we go. Find the exact value of x. And we've got, and we have 30 degrees right there. And we have, I don't know, 12. Actually, I shouldn't do that one. That's the easy one. 12 and x. My 12 looks stupid. Okay, so this kind of problem would be on a no calculator portion. You'd have to be able to solve this problem without using your calculator. So First thing we figure out is what trig ratio is involved in this problem. Sine, cosine, or tangent. What is 12 to the 30 degrees? Is it opposite, adjacent, or hypotenuse? Adjacent. True. What is x? Hypotenuse. So we've got adjacent and hypotenuse. So which trig function are we talking about?
The cosine?
Cosine. So the cosine of 30 degrees equals the adjacent over the hypotenuse. What is the cosine of 30 degrees? Square root of 3 over 2.
And what did you ask?
I asked what was the cosine of 30 degrees. Okay. And then we can solve for x. So x times the square root of 3 equals 24. We follow what I did? Just a little proportion, right? Cross multiply. Right? Okay, I'll wait.
Square root of 3 over 2 is, wait, am I looking?
Cosine of 30 degrees.
I was looking at the wrong thing.
Okay.
You may have been looking at 60 degrees.
Yeah.
Yeah.
Okay, so it's 12 times 2 is 24. Yeah, square root of 3.
Got it.
And then we divide by the square root of 3 and get x equals, oh no, we got to rationalize it, times the square root of 3 over the square root of 3, right? So x equals 24 times the square root of 3 over 3. Can we reduce it?
Yep, that's
We
going to be 8 square root of 3.
It is. So the exact answer, no need for approximately equal to. This is math class, not physics. 8 times the square root of 3. Easy money, right? Now,
Why did the 3 disappear?
Because 24 divided by 3 is 8.
Oh, I see. Yeah, that's how you got it.
okay. Easy money?
Yes.
Great.
I got it.
You got this. You can do it. So, sine is a ratio of sides. Inverse sine gives us, of the ratio, gives us the angle. Let me show you what I mean.
No, the whole bottom words, I don't think any of them are registered.
It'll make more sense when it's when it's a pretty picture on the board. Okay. No. Okay, so the sine of theta is the opposite over the adjacent, right? The inverse sine which we write as sine -1 of the opposite over the hypotenuse is the angle. Now, there's another way to write this that you'll see on some calculators, some textbooks, some things. The inverse sine is also called the arc sine. Okay. Now, the same applies for cosine, tangent, and all the other ones as well.
Arc sine is that whole chunk? Sine -1 opposite hypotenuse?
That's this.
Oh, okay. Just the opposite hypotenuse bit?
Just this
Just
bit.
the sine angle.
Yes. So the inverse cosine, this is kind of a more modern way to write it. This is an older way to write it. But you definitely still see it some places. The adjacent over the hypotenuse equals the angle And that will be the arc cosine, which I don't remember whether that's spelled with 2 C's or not. And they don't use that word at all, but we'll pretend like it is. You can look it up and prove me wrong later. Be totally fine. And the inverse tangent works the same way. Same for all the reciprocal ones, but we won't write those for this. We won't usually use those. We'll be, oops.
Opposite of adjacent.
Yes, that's what I meant to be writing, although I was writing something different. You caught my mistake and you didn't even know it.
Accidentally.
You're like a magic man. So, if you are doing guided practice 5A, I'll just kind of explain this and then I'll let you leave. The rest of the examples in the book are like some, mostly like kind of physicsy problems. And so you can look at them. We probably we'll get some word problems on your homework. If you need help on them, we can hit that next class. What am I saying? Oh, like on guided practice 5B, on bottom of page 223. So which trig function are we looking at in that particular problem?
That is the adjacent or the hypotenuse.
True, which is which trig function?
Which is, I don't know.
So, O, Ka, A with A, Ka, C, A, H.
And it's cosine.
Ka. So I'm telling you things that are useful. So, Ka, Toa. Say it out loud. So, Ka. Not so, Ko, Toa. So, Ka. It's very important we get the O and the A separate. So, Ka, Toa. I didn't know I was going to be learning weird words. So, Ka, Toa. Yeah? So that's cosine. So like what you would punch in your calculator is the inverse cosine of 5/12, enter. And it'll give you the answer. Just make sure you use the inverse cosine, which is probably shift or second and then cosine, probably.
65.
It is.
7, 5, 6.
Yeah. Now the thing says around in the nearest degree, so 65 degrees. But yeah. That's it. I'm going to give you your homework right now. I am not necessarily promising I'm going to remember to put it in time on the other, but it is Thursday, so the chances are better. But my life is pretty topsy-turvy right now, so I will do my best. But I'm giving it to you now for sure. So, okay. I want y'all to do, yeah, that works great. That works great. Homework, which is going to be on page 227. And I would like y'all to do 2 through, make sure there aren't any on the other page. I think, do I want to give you more word problems? You're in physics, you're in physics. Have you already had physics? You did physics? I guess 2 is fine. So 2 through 38 evens, which is not much, especially since we only have 1 lesson over the weekend. We'll get back to normalcy before I've already caught up on one chunk of my life. I think we can get the rest over the weekend. At least that's the plan.